Hi, in this video we're looking at Skill Builder 11.4 on the combined gas law. So just as a refresh, we've already looked at Boyle's law, and Boyle's law is the relationship that when volume increases, pressure decreases, and this is an inversely proportional relationship. So we say that volume is inversely proportional to pressure. So if volume goes up, pressure goes down. If volume goes down, pressure goes up. Charles's law is the relationship between volume and temperature, and we see that for this law, as volume increases, temperature will also increase, and vice versa. Because they both increase or they both decrease, we say that the relationship between volume and temperature is a direct relationship. So whatever happens to one will also happen to the other. So when we combine these two laws together, what we see is that volume is directly proportional to temperature, but indirectly or inversely proportional to pressure. And we can put those together in the following formula, which is that the initial pressure and the initial volume over the initial temperature is going to be equal to the final pressure, the final volume, divided by the final temperature. The great thing about the combined law is that we can look at how gases behave under these three variables: pressure, volume, and temperature. So let's look at how we can use this formula to solve a problem. So we have a balloon has a volume of 3.7 liters at a pressure of 1.1 atmospheres and a temperature of 30 degrees. So these are all of our initial amounts. So we have volume 1 is equal to 3.7 liters. We have our pressure 1, our initial pressure is going to be 1.1 atmospheres in the balloon, and the temperature of the gas in the balloon is going to be 30 degrees Celsius. Now we have to look at our final variables. So we take the balloon and now we submerge it in water to a depth where the pressure is 4.7 atms and the temperature is 15 degrees Celsius. What is its volume? So our final volume is what we're looking for in atms, in atmospheres. Our final pressure is 4.7 atmospheres, and our final temperature when it's submerged in the water is 15 degrees Celsius. So one thing that I like to do is I like to predict what's going to happen with these changes in the variables. So first of all, we see that we're going to have our volume. Oh, we don't actually have our volume yet. That's what we're predicting. So what happens to our volume when our pressure increases? So we're going to have an increase in our pressure, but our temperature decreases. And what we know is that our volume, when our pressure increases, is going to be an inverse relationship. So if our pressure increases, our volume should decrease. And if our temperature decreases, there's a direct relationship to that. So our volume will decrease with that variable. So having pressure increase and our temperature decrease, we should have the same result, that our volume is going to decrease as well. So let's go ahead and see if we can prove that prediction based on this formula here. But before we do that, we have to make sure that our units are copacetic with this formula, which means that our volume needs to be in liters and our temperature needs to be in Kelvin. Now, our initial volume is in liters, so we don't have to convert that, but our temperatures are given in degrees Celsius, so we're just going to add 273 to that, which will give us 303 Kelvin. 303 Kelvin here. We don't have, that's the volume we're trying to find. So we're going to add 273 to 15 degrees Celsius, and that's going to give us 288 Kelvin here. Now we can plug these units into our formula. So P1 is 1.1 atmosphere, and our volume is 3.7 liters for our initial volume, and our initial temperature is 303 Kelvin, and that's going to equal our final pressure of 4.7 atms, atmospheres. We're looking for our volume 2, and that's going to be over our temperature of 288. I'm going to solve this side first. We have 1.1 times 3.7 gives us 4.07 divided by 303. That's going to give us 0.01343, and I try and keep all of my numbers and keep the rounding to the very end. And that leaves me with 4.7 times my final volume over 288. Now I'm going to isolate my volume, so that means I'm going to bring the 288 over to that side and the 4.7 using algebra. So I'm dividing by 288 here, so to cancel that out I'm going to multiply by 288, and whatever I do on this side I also have to do on the other side, so I'm going to multiply by 288. And that's going to give me 288 times 0.0134 gives me 3.8685 is equal to 4.7 times my final volume. Now I'm going to bring the 4.7 to the other side by doing the opposite operation. So I'm multiplying here, so to do the opposite it will be dividing by 4.7. That cancels that out, leaving my volume, but whatever I do on one side I also have to do on the other. And then that's going to give me 3.8685 divided by 4.7 gives me 0.823 liters is equal to my final volume. And you can see that where my initial volume was 3.7 liters, that's how much gas was in the balloon. You can see that it shrank down to 0.823 liters, and that's what I predicted through Boyle's and Charles's laws, that volume would decrease because my pressure is increasing and my temperature is decreasing. So let me just pull back from here a little bit, and you can see the whole calculation right here. So that's it for Skill Builder 11.4. Thank you for watching.